Welcome to this explainer. Today, we're taking some seriously complex genomic and archaeological data and turning it into a clear, chronological journey. We're going to map out exactly how humans first populated the Americas, tracking their footprints all the way from frozen tundras to the very tip of South America. So let's dive right in by confronting the massive frozen elephant in the room. I mean, imagine trying to settle a brand new world, but the front door is completely sealed shut by an actual wall of ice. This was the harsh reality of the last glacial maximum, the absolute peak of the Ice Age. The sheer scale of this problem was just staggering. We're talking about an impenetrable frozen barrier formed when the Cordilleran and Laurentide ice sheets coalesced east of the Rocky Mountains. It completely blocked human migration from the Beringia land bridge down into the North American interior. There was literally no way through. The frozen barrier opens, surviving the ice. We start our epic ride at the peak of the Ice Age, a time when the climate itself dictated exactly where humans could and couldn't go. Now, the crucial thing to notice here is how this ice slowly, stubbornly yielded. From 26,000 to 19,000 years ago, migration routes were totally locked down. But by around 17,000 years ago, coastal alpine glaciers finally started to pull back. And it wasn't until much, much later, around 13,000 to 12,000 years ago, that a full inland ice-free corridor opened up. While those massive ice sheets were merged, people were basically trapped. If they tried to push inland as the ice melted, they hit this brutal landscape of glacial outwash and giant ice-dammed lakes. But along the coast, there were these unglaciated coastal refugia, safe havens on islands that actually managed to sustain terrestrial and marine life. Two routes south, coastal versus inland. As the Great Thaw began, the incredible migration southward finally kicked off. Because the coastline thawed first, early humans likely took advantage of those retreating coastal glaciers. They started island hopping, moving from one coastal safe haven to the next, inching their way south into totally uncharted territory. By about 17,000 to 15,000 years ago, a Pacific coastal route opened up and became truly viable. This was a huge deal. It meant that folks with a maritime-adapted lifestyle could completely bypass that frozen, flooded interior, traveling down the coastline where food and resources were way more predictable. Meanwhile, literally thousands of years later, around 13,000 years ago, a second path finally became biologically viable for human travel. This was the famous inland ice-free corridor, which carved a dry path right down the center of North America. So pitting these two grand migration models against each other, you have the rapid, earlier coastal migration hugging the shoreline on one hand, and on the other, you have the much later, slower movement pushing through that interior corridor once the ice finally parted. But here's the million-dollar question. Did a single group populate the rest of the continent, or were there multiple ancestral streams? Once these pioneers made it past the ice, the story gets incredibly complex. And our own modern DNA holds the ultimate clues. The Great Genetic Divide, Northern and Southern Lineages. Recent advancements in ancient DNA have completely upended our understanding of what happened next. The real turning point came from the genomic data of an ancient child known as Anzac I, who was buried in Montana about 12,600 years ago. His genome proved, beyond a shadow of a doubt, that a massive genetic divergence occurred shortly after humans arrived in the Americas. When we compare the main lineages, a super fascinating picture emerges. The Anzac I child was closely related to the southern Native American lineage, populations we find today in Central and South America. He was much less related to the northern Native American lineage, which includes groups like the Cree and Ojibwa. This means the ancestral population actually split and developed two distinct geographical footprints over 12,600 years ago. As geneticists Skoglund and Reich put it, this suggests that the present-day structuring of the main ancestry in Native Americans into northern and southern lineages dates back to more than 12,600 years ago. The deep genetic structure we see today isn't recent at all. It was baked in incredibly early. So, are there other hidden ancestral streams waiting in the DNA? We know about the northern and southern lineages, but the mystery thickens even further when we take a close look at certain populations living deep in the Amazon basin. The Australasian mystery, population Y. Now, prepare to have your mind a little bit blown by a statistical anomaly that scientists are still trying to explain. 2%. It sounds tiny, right? But modern Amazonian populations, specifically some groups who speak Tupi languages, possess about 2% of their ancestry from a group far, far away from the Americas. This tiny but undeniable genetic signal links them to modern Andaman Islanders and Australo-Melanesians. Scientists dubbed this ghost lineage Population Y, from the Tupi word meaning ancestor. It implies that a completely distinct, unmixed stream of ancestry, likely a structured subpopulation from Northeast Asia, somehow made it deep into South America without mixing with the main Native American lineages along the way. Wild, right? So, did the migrations just stop there? With the continent fully populated from the Arctic all the way down to the deepest parts of the Amazon, you might think the borders were closed, but no, the story wasn't over. Later, Arctic migrations, the Paleo-Eskimo and Thule. Fast forward a few thousand years, and the North American Arctic becomes the stage for a completely new series of dynamic migrations from Asia. The Arctic actually saw two massive, distinct later waves. First, roughly 4,500 years ago, the Paleo-Eskimos, represented by the Sakak and Dorset cultures, arrived and introduced brand new ancestry. Then much later, about 1,000 years ago, the Thule culture arrived. The Thule are the ancestors of present-day Inuit populations, and their arrival drove a massive population turnover up in the high Arctic. When you step back and look at the whole genomic tapestry, it's honestly breathtaking. What started as a single group trapped behind a massive wall of ice eventually blossomed into at least 4 distinct streams of Asian ancestry, breeding together to populate a vast, incredible hemisphere. Which leaves us with a huge question. With ancient DNA constantly rewriting our timelines, what other forgotten populations are still waiting to be discovered in the genomic record? If we're still unearthing lost lineages like Population Y today, whose forgotten footprints might we find next? Keep learning, keep questioning, and thank you for joining me on this explainer.